Let us discuss the nth order derivative of some standard functions. So let us consider a standard function y equal to e power ax. When we differentiate it once with respect to x, we get y1 which is equal to a into e power ax. So you all know that the derivative of e power ax is a into e power ax. Once again differentiate this with respect to x to get y2 which is equal to a square e power ax. Similarly differentiating it for this next time, y3 equal to a cube e power ax. And for the nth, differentiating it n times, we get yn which is equal to a power n into e power ax. So this gives you the nth order derivative of e power ax. Now let us consider the second standard function y equal to ax plus b whole power m. Differentiating x with respect to n times. That is differentiating for the first time, we get m into ax plus b whole power m minus 1 into a. So this is differentiated using chain rule, right? You know that the derivative of x power n is n into x power n minus 1. So similarly here, the derivative of y is m into ax plus b whole power m minus 1 into derivative of ax plus b is a. Then differentiate y1 once again with respect to x to get y2 which is m into m and a are constants. Differentiate ax plus b whole power m minus 1 with respect to x. So you will get m into m minus 1 into ax plus b whole power m minus 2 into a, that is a square. Similarly, once again differentiate with respect to x, y3 is m into m minus 1 into m minus 2 etc. ax plus b whole power m minus 3 into a cube. So generalizing this, we obtain the nth derivative yn which is equal to m into m minus 1 into m minus 2 etc. m minus of n minus 1 into ax plus b whole power m minus n into a power n. So here, how do we write the last term? So if you see the third order derivative, you have three factors, m into m minus 1 into m minus 2. So here we are writing 2 and ax plus b whole power m minus 3. The power is m minus 3. So 1 less than 3 is 2. Similarly here, the power is m minus n. 1 less than n is n minus 1. Hence we get the nth derivative of ax plus b whole power m as m into m minus 1 into m minus 2 etc. m minus of n minus 1 into ax plus b whole power m minus n into a power n. Now let us derive the nth order derivative of the function y equal to sine of ax plus b. Differentiating y with respect to x, we get y1 which is equal to a into cos of ax plus b. So differentiating sine, we get cos, and using chain rule, derivative of ax plus b is a. So now if you differentiate it once again, you will get y2 which is equal to derivative of cos of ax plus b is minus sine of ax plus b into derivative of ax plus b is a into a is a square. And then differentiating it once again, we get y3 which is equal to minus a cube into cos of ax plus b. So from these derivatives, we cannot generalize for the nth order derivative. Hence, we convert this first order derivative into the given function, that is the sine function. So I can write cos of ax plus b as sine of pi by 2 plus ax plus b. And I'll get y1 equal to a into sine of pi by 2 plus ax plus b, which is in the given form, the given function form. Then differentiating this with respect to x, now we get y2 which is equal to a square into cos of pi by 2 plus ax plus b. We get this a square, that is by differentiating sine we get cos, and derivative of pi by 2 plus ax plus b is a into a is a square. Then once again I'll write the given this y2 in terms of the given function sine function, that is just by adding the angle pi by 2. So I'll get a square sine of pi by 2 plus pi by 2 plus ax plus b, which is a square sine of 2 pi by 2 plus ax plus b. This is the second order derivative. Differentiating y2 with respect to x, once again we get y3 which is equal to derivative of sine of 2 pi by 2 plus ax plus b is a into cos of 2 pi by 2 plus ax plus b into a square becomes a cube cos of 2 pi by 2 plus ax plus b. Then we can write this in terms of sine by adding pi by 2, angle pi by 2 with this angle. So we get 3 pi by 2 plus ax plus b, and hence we can generalize and we can write the nth derivative yn as a power n sine of n pi by 2 plus ax plus b. So this is written just by saying y3. So in y3 you have the power of a is 3 and sine of 3 pi by 2. So you have 3 multiplied by pi by 2 plus ax plus b. Hence we generalize for the nth derivative, yn is equal to an into sine of n pi by 2 plus ax plus b, which is the nth derivative of sine of ax plus b. Now let us obtain the nth derivative of another standard function e power ax into cos bx plus c. So let us consider y equal to e power ax into cos bx plus c. Differentiating with respect to x, we get y1 equal to, so now I'll apply the product rule. Derivative of e power ax is a into e power ax into cos bx plus c, and then derivative of cos bx plus c is b minus b into sin bx plus c. So I'll get minus b into e power ax into sin bx plus c. So now to write this first order derivative in terms of the given function e power ax into cos bx plus c, I'll make the substitution a equal to r cos theta and b equal to r sin theta in y1. So what are r and theta? Where r is equal to root of a square plus b square. This is obtained by squaring a and b and then adding. So a square plus b square will give you r square cos square theta plus r square sin square theta, which is r square, and from that you will get r is equal to root of a square plus b square. Then b by a will give you r sin theta by r cos theta, where r will cancel and sin theta by cos theta is tan theta. So from that theta is equal to tan inverse of b by a. Then substituting these in y1, we get y1 equal to e power ax into r cos theta into cos bx plus c minus e power ax into r sin theta into sin bx plus c. So now r into e power ax is common. I'll take that out as common factor. Into you will get cos theta cos bx plus c minus sin theta sin bx plus c, which is nothing but cos of theta plus bx plus c. So I'll get y1 equal to r into e power ax into cos of theta plus bx plus c, which is in the form of the given function. Now differentiating with respect to x once again, we get y2. So differentiate r is a constant. Differentiate e power ax into cos of theta plus bx plus c using product rule. So we get r into derivative of e power ax is a into e power ax into cos of theta plus bx plus c, and then derivative of cos of theta plus bx plus c is minus b into sin of theta plus bx plus c into e power ax. So again, once again, we substitute a equal to r cos theta and b equal to r sin theta. So we get this r into e power ax into r cos theta, substituting for a, e power ax is taken out as common factor, then cos of theta plus bx plus c minus r into sin theta into sin of theta plus bx plus c. So now r is again common. I'll write it as r square into e power ax. Cos theta into cos theta plus bx plus c minus sin theta into sin theta plus bx plus c using cos a cos b minus sin a sin b, which is cos of a plus b. I'll get cos of theta plus bx plus c, which is r square e power ax into cos of 2 theta plus bx plus c. So this is the second order derivative. Once again differentiating this with respect to x, we get the third order derivative y3, which is r cube. So I can write from the second order derivative the third order derivative y3, which is r cube e power ax into cos of, you have 2 theta in y2, so it should be 3 theta in y3, 3 theta plus bx plus c. So this is the third order derivative. From the third order derivative we can generalize and write the nth order derivative. So in general the nth order derivative yn can be written as r power n e power ax into cos n theta plus bx plus c. So in third order derivative you have r cube e power ax. So the power to r is 3 e power ax into cos 3 theta plus bx plus c. So we can generalize for n, yn is equal to r power n into ax e power ax into cos n theta plus bx plus c, where r is root of a square plus b square and theta is tan inverse of b by a, and hence we can write the nth derivative in this form, that is a square plus b square to the power n by 2 e power ax into cos n into tan inverse of b by a plus bx plus c.